Okay, so we're going to finish up section 6.3. We've looked at all the transformations individually now, the shifting and the stretching. Now we're gonna put it all together. So the order that we do the transformations in, that becomes important. So let's start. Let me write out kind of a template, and then I'll label it so we can kind of review what does what. So let's just write down y equals c times the sine of, I'm trying to think which letters I used. Bx plus or minus a, and then plus or minus d. Each one of those letters is one of the 4 transformations that we studied this week. Let's start with the transformation you would do first, which is a. Does anybody remember what adding or subtracting does inside parentheses? Yep.
He shifts it left or right.
Yep, that's our horizontal shift. And what did we call that? When we do a trig function, I call it a little different name. Yep.
Phase shift?
That's a phase shift. So when you're graphing a trig function with multiple things in it at the same time, if there's a phase shift, you would do it first. So what I'm about to put here, this list, is the exact same thing as what I wrote in red. It's just this is going to be listed as numbers, and then up here, it's just listed as an equation. All right. How about B? B is the second thing we would do. And does anybody remember what multiplying by a number next to the x does? Yep.
Horizontal stretch.
Yep, that's your horizontal stretch. So I'll write that underneath it. So this is a horizontal shift. This is a, let's see if I can move this up a little bit. That's good. So that's the horizontal stretch. And does anybody remember what we called that one? Yep. Amplitude is something different. Horizontal stretch or compression changes the one. Yep.
Frequency.
Yes, the frequency, which we call
The period.
the period. Yep. So this is a period change. And that's the second thing that you always do if you have multiple in the same problem. Okay, third thing you would do is C. Now we're outside the argument. Okay, we're not inside parentheses anymore. Multiplication outside the parentheses. Does anybody remember what that does? Yeah. That can affect the amplitude. Yep. And what do we, so that's an amplitude change. I'll put that up here. And if we describe that using the type of language we've used before, changing the amplitude is really a Declan? That's a vertical stretch. Okay, so vertical stretch. And the last one is D. I'm just going to put it down there. You are outside the argument, and you are either adding or subtracting. What would that do? Yep.
Vertical shift.
That's your vertical shift. And there really isn't another name for that I can put in parentheses. It's just called a vertical shift. Okay, when we're shifting left and right, if A is positive, which way would it move you? If A is positive, yep. It would move you left. And if it's negative, it would move you, yep, right. How about with a vertical shift? If D is positive, it would move up. And negative, down. So we talked about all those details when we did each individual transformation. What else? How about if C was a negative number? Well, we know it stretches or compresses, but if it's negative, it also does something else. Yeah?
Does it invert it?
Yeah, it flips it. Okay, it's going to flip it vertically. The bigger you make C, the bigger it stretches. The smaller you make C, the more it compresses. B is the opposite. The bigger and bigger you make B, the more and more squished the graph gets. The smaller you make B, the more stretched it gets. Okay, I didn't write down all those details here because that's a lot of stuff to add, but we went over each day. Okay, so any question on the order, which is the same exact order that we've been doing all year? Okay, so let's try an example. So this one says to graph 2 sine x plus pi over 2. Let's just label what these are first. So we've got 2 transformations, addition inside the parentheses and multiplication in front. Alexis, what's the addition inside the parentheses? What kind of transformation is that?
So horizontal shift.
Yep. So that's our horizontal shift. And what about the 2 in front? What's that going to do? Yep. Yep, that's going to be our vertical shift. Vertical, wait, what'd you say? Stretch, yeah. So, vertical stretch. Okay, so now we look at the chart and look at the order. If you're missing one, you just skip it. But if we have it, we need to do them in the order that I said. So what would be the first one we should take care of here? Yep.
The horizontal shift.
Yep, we always would do the horizontal shift first. So what we're going to do, let's start out by doing this problem just like the 2 wasn't there. Okay. Let's just do sine of x plus pi over 2 first, and then we'll deal with the vertical stretch after. Okay, horizontal shift is going to move it left and right. Which values are affected when you move left or move right? Yep.
EX value.
The x values. Let's put the originals off to the side. And the first thing is, are we going to add or are we going to subtract something from all those x values? Think about which way plus is going to move the graph. Caleb? We're going to subtract something. Can you tell me what we're going to subtract?
Subtract pi over 2.
We're going to subtract the pi over 2. Yep. And we'll put our answers right there. Okay, Sam, what's 0 minus pi over 2?
Negative pi over 2.
Yep, negative pi over 2. Aiden, what's pi over 2 minus pi over 2?
0.
0. Yep. We can do the common denominator if we need to, or if at this point you start to see the pattern, we can just go with the pattern. But does anybody see what pi minus pi over 2 is? Yeah?
Pi over 2.
It's pi over 2. How about 3 pi over 2? Take away 1 pi over 2. Reduced. Yep. That's pi. And how about 2 pi? Take away pi over 2. Jalen, you see what that one would be? Yep, 3 pi over 2. Good. Is there any questions on how to get those x values? If you see the pattern, go with it. If you don't, you're going to have to do the common denominator to get it each time. But what you don't want to do is decimals. We don't want to see like 3.14. We don't want decimals here. Okay, so we got the x's. Now we need to also change the y's. At this point, we would normally be done because there'd only be one thing to do, but we have a second thing to do. Okay, we're doing sine. How about, Anthony, what are my y values for sine? And I'm going to put them on the outside because they're just my originals.
0, 1, 0, -1, 0.
Okay, so those are the originals. And Lucas, what am I going to do to all the original y values to deal with that transformation?
Multiply them by 2.
Yep, I'm going to multiply them all by 2. So we get 0, 2, 0, -2, 0. So there's a problem that had multiple transformations in the same equation. All right, now we sketch it. I am going to scale both axes this time. I'm going to scale my y-axis to go by 2's. And I'm going to scale my x-axis to go by my labels in the x column. So this will be -π/2, 0. Again, it's a little hard to see, but I made the y-axis bold. That has to be 0. An axis can't be any number other than 0. Some people try to make it a different number. You can't do that. Pi and 3π/2. Okay, so you don't need a very big piece of graph paper here. You just need like a small little section to sketch your problem. All right, so -π/2, 0. 0, 2. π/2, 0. Pi, we're at -2. And 3π/2 back to 0. It doesn't look like a vertical stretch because I scaled my axes instead of drawing my graph twice the size. Questions on the table or the sketch? Okay. Let's try. I say, let's do this one. 3x minus π/2. Sorry, 3x minus π/2. Now, the last one, I told you you had to follow a certain order when you did it. If we go back and look at it, horizontal shift, what values did that affect? Yeah? That affected the x's. And the vertical stretch affected the y's. So technically in this problem, each transformation was totally separate. They were each on their own axis. The order becomes very important when you have two things happening on the same axis, like shift up and then vertical stretch. Now we've got two things happening and it makes a difference with the order. Technically the order didn't matter in this one, but I would always stick with the same order and then you won't have to figure out whether you should follow the order or not. Just always follow. Here, it wouldn't be important to follow the order because this is a vertical stretch. This is a horizontal stretch. Each transformation here is on its own separate axis. They have nothing to do with each other. But in this one, that's not true. We have a phase shift, which is a horizontal shift. And we have a period change, which is a horizontal stretch. Or compression, one of the two. Both of these transformations are going to affect the x values. So the order is important. the y's are going to stay the same in this problem. Nothing happens to the y's at all. Okay, so what I would do, because we're doing two things on the same axis, is break this problem down into two littler problems. Which transformation would we do first? The shift or the stretch? Yeah. Yep. So let's pretend like the problem was y equals sine of x minus pi over 2. Let's see. Let's do this one first. So we'll handle the shift. And then once we get this answer, we'll use that answer to do the stretch. Okay. So shifting left and right. What column stays the same when we shift left and right? Yeah.
Y.
The y's. So my y values for sine are 0, 1, 0, negative 1, 0. My original x's are 0, pi over 2, pi, 3 pi over 2, 2 pi. And Eileen, am I going to add or subtract something to all of those? Well, when we subtract, which way is the graph supposed to move? Left or right?
To the right.
It's supposed to move to the right. So as x values move to the right, what happens to them? Do they get bigger or smaller? They get bigger. So we need to add. That's the only way to make x values bigger. You need to increase by adding. And Sam, what am I going to add to all of them?
Positive pi over 2.
Yep. So we're going to add pi over 2. Okay, now remember, that's not the final answer. That's just doing the phase shift first. We still have to go back and do this horizontal stretch after. You can do both at the same time if you can do it all in your head, but I think it gets too confusing with all the fractions. If you had to do two things to the y values, that's a little easier because the arithmetic doesn't involve any fractions and the numbers are simple. But don't try to do two things with x in your head. Okay, Chris, can you tell me what my first x value will be?
Pi over 2.
Yep, pi over 2. Y at my second x value? Pi. Okay, Matt, my third one?
It's like 2 pi over. Wait, no, 3 pi over 2.
3 pi over 2. Yeah. And then Matt, my fourth one?
Yeah, that's going to be 3 pi. No.
Well, it's 3 pi over 2 plus 1 pi over 2.
So 2 pi.
2 pi, yep. It'll be 4 pi over 2, which reduces to 2 pi. And Eli, my last one, 2 pi plus pi over 2.
That'd be 5 pi over 2.
5 pi over 2. Yep. Okay, so there's the horizontal shift. Okay, that's done. Now, we're going to take that answer and we're going to modify it again to do the horizontal stretch. Okay, so let me move this out of the way. Oh, that's not. Let's go. Okay, we're going to take this table and we're going to do a horizontal stretch to it. Max, when I stretch and compress horizontally, whichever one it happens to be, is that going to affect the x column of this table or the y column? It's going to affect the x column. So I can copy the y column over. That stayed the same. So we've got 0, 1, 0, negative 1, 0. As far as what I'm going to be grading on the test, it's what's in this black box. I'm looking at the final answer to this problem. Okay, and who can tell me what we have to do to all these x values to get the new ones? Yep. We can multiply, but it's not by 3. Or we can divide, and then we can do it 2 ways. Yeah?
You do like 2 pi divided by 3.
If I was asking you for the length of the period, then you would do 2 pi divided by 3 and say that's the length of one cycle. But not for the table. Matt?
We could multiply everything by 1/3.
Yep, we can multiply by 1/3, or you divide everything by the number in front of x, which is 3. Okay, I'm going to think of it as multiplying by 1/3. So I'm just going to, off to the side, put my original x's. Remember, the original this time means the ones we have in this table, not the ones back from the original tables on Tuesday. So pi over 2, pi. 3 pi over 2. 2 pi, 5 pi over 2. And as Matt said, let's divide them by 3 or multiply by 1/3. And if we do a couple of them, you're going to start to see the pattern. So we've got pi over 6. What's the next one? Kelly, do you see the next one?
Pi over 3.
Yep, pi over 3. All right, how about the next one? Matt?
Pi over 2.
It's going to be 3 pi over 6, but that reduces to pi over 2. Okay. Jazara, how about the fourth one? Yep, 2 pi over 3. Good. And the last one? Yep.
5 pi over 6.
5 pi over 6. Yes. Again, pattern here. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. There's your pattern. Okay, and that's your table. Any questions on how we got either the red or the black table? Black table is the final answer. Red table is kind of the first step. Okay, so now we got to sketch it. Since the y's only go from 1 to -1, there's no reason really that I don't know why I exactly did this grid. I might not even use that grid because that's not really what I need. I want to draw my own. Okay, 1 to -1. And I need x values starting at pi over 6, pi over 3, so I need 1, 2, 3, 4. I need 5 tip marks. This will be 0. This will be pi over 6, pi over 3, pi over, forgot the other one, pi over 2, 2 pi over 3, and 5 pi over 6. And the labels, if you did it in degrees, I think you'd see a lot easier the pattern. This is 0, 30, 60, 90, 120, 150. It's like plus 30 each time. It doesn't look like that at all when you do it in radians, okay, but it is. Any questions about why I put those labels there, or the labels that I did on the y-axis? Put 0 in if you want. Okay, make your sketch. So pi over 6, we're at 0. Pi over 3, we are at 1. Pi over 2, back to 0. Negative 1 and 0. Okay, so that's our sketch. A little bit more complicated than the last one because you had to handle 2 transformations happening on the same axis. And when that happens, I usually do 2 tables, so I don't have to do it all in my head. Any questions on that? All right, as far as sketching by hand, that's pretty much it for today. Does anybody have any questions before we move on to some calculator stuff? This will really be the last chance to ask me about sketching and making a table. So when a problem says sketch, that means, take out a piece of paper, draw it out. When a problem says find a complete graph, that's a calculator question. So the first thing it says is find a complete graph of 4 sine 3x. Okay, let's put that in. So anything else you have in there, you just clear it out. Put in 4 sine 3x. That's what it should look like when you type it in. Exactly the way it's pretty much written. Again, we talked about this yesterday. Whether you put the 3x in parentheses or you don't, it doesn't matter. Okay, I'm going to make sure my calculator is in radians. I don't know, I think we talked about switching the mode, but you just press mode and it's the 4th one down. Change it to radians. And before I hit graph, what do I always want to, I have to adjust it to look right. Yeah?
You have to hit zoom 7.
Right. You have to adjust the window. If they tell you specific things to use for the window, then you're going to go to window and you're going to type them in. If they don't give you something specific, zoom 7, it's kind of like zoom 6. It's a good starting point. Window's okay. I mean, it does technically show everything. It's a little close to the edge on the high and the low because we've stretched this by a factor of 4. When you do zoom 7, it sets the Y min and the Y max to 4 and negative 4. So it just barely fits on the screen. What I would probably do is after you do zoom 7, change it to like negative 6 to 6. That'll give you a little bit more room on the y-axis. But if you use the other window, I wouldn't mark that wrong. I mean, it was okay. There's your sketch. Okay, so we've got a complete graph. Now we want to find 4 things: domain, range, amplitude, and period. Yes?
My calculator is very messed up. I put in radians and it's like doing weird up and down.
And you did the zoom 7?
Yeah, it's changing the heights of each wave.
And you typed it in exactly like that, 4
Yeah.
sine, and then in parentheses 3x. Go back to y equals. Not sure, but there's some funny symbols there. They don't look like.
Yeah,
See how the y3?
I can change them to other things, but not the slash. That's there.
Is that one of yours or is that mine? Okay.
But it's been fine since then.
Yeah, there might be something. something strange going on there. I'm not sure.
Changed it.
Yeah, we'll have to see. Try graphing it on like Y7 or Y8 instead of using Y1 and Y2 because something looks funny about those. We could just reset it to fix them, but it would lose everything you have on the calculator if you put stuff on. So try Y7 or 8 and let me know. All right, let's start with the domain. So look at that graph in blue. What does it look like the domain is? Yep, all real numbers. You can take the sine or cosine of any number you want. There's no breaks, there's no gaps, there's no holes in the graph. You can put your pencil down, and you can draw forever and lift it when you're done, and you never have to lift it before you're done. Okay, so the domain is always all real numbers for a sine function. Did that work, Lucas?
No.
No. Okay, let me look at it at the end of class. Okay, so there's your domain.
This.
How about the range? It's not all real numbers. The range is very limited. It's right there. Yep.
It would be, is it 4? Is that 4?
That's
Negative 4, and then up to positive 4?
Yep. And can somebody tell me how do we write that? -4 to +4, and it does include them. Yep.
It would be -4, 4 with brackets.
Yep. There you go. So there's your domain and your range. Amplitude and period. These are two things we talked about yesterday. What's the amplitude of? You don't even need to see the graph to really do that. Just look at this. What's the amplitude of that equation? Yeah?
It's 4.
It's 4. It's the absolute value of the number in front. And now, the period, somebody mentioned this earlier about taking a number and dividing by something. That's what we want to do now. So, when we want to find the period of the sine function, can someone just tell me what's the formula we use? What over what in general? Yep.
2 pi over b.
2 pi over b. And how do you find b?
B is whatever number is next to x.
B is whatever number is next to x. So in this case, 2 pi over b is going to be 2 pi over 3. And that's your cycle length. So if you wanted to graph this and you only wanted to see it do one cycle, like here you're looking at a bunch of cycles. Maybe you're looking at like 7. I don't know. There's a lot of them. But if you only wanted to see one cycle, then you need to set your window so it's exactly that many units wide. So the easiest way to do that is to start at 0 and stop at 2 pi over 3. Oops, I messed that up. It's not quite working. 2 pi, or I'm not working. All right, so if you set your window to go from 0 to 2 pi over 3, you just set the width of your screen to be exactly 2 pi over 3. So when you hit graph now, you're not going to see it go up and down a bunch of times. You're going to see it do exactly one cycle. Now, if you wanted to see 2 cycles on the screen, you would need to set your window so that it has a width of double the period. If you double the length of this number, what do you get? Yeah.
4 pi.
Right. If you double the length of that, you get 4 pi over 3. So if you want to see 2 cycles on the screen, set your window so it's exactly twice as wide as 2 pi over 3. So just put in 4 pi over 3, hit graph, and now you'll see exactly 2 cycles. So you can change how many cycles you see on the screen by basing the width of the window on the number that's the period. I generally, if I have to sketch something, I don't really think there's a need to show more than 2 cycles. There's no reason you have to show like 7 like that. But hey, it's not wrong, it's just that's kind of a lot. Okay, any questions on finding domain, range, period, or amplitude? Okay, let's try another one. So it says find a complete graph, and then domain, range, period, and amplitude. Okay. So let's put in 3 sine x minus 1. Okay, so that's what it should look like when you type it in. I'm going to start with zoom 7. That's fine. Probably showing more cycles than I really need to here, but that's not that bad. So that's a good one. And let's go through all 4. Okay, start with our domain. Okay, Aiden, what's my domain for this one?
All real numbers.
Yep, it's all real numbers. Sine and cosine always have all real number domains. Because again, you never have to lift your pencil when you're drawing. So domain, all real numbers. Right, how about my range? What's that?
3 and
Negative 3 to 3. Normally it would be negative 1 to 1, but you tripled it. So now it's negative 3 to 3, brackets or parentheses?
parentheses.
Parenthesis would mean that we never hit the value 3, but we do actually hit it right there. So, brackets. So there's our range. Okay. Alexander, how about our period? What's going to be our period? Two pi, right? The period of this is not changed. The formula would be 2 pi over b. B is 1. So period is 2 pi. Domain, range, period. What else do they want? Oh, amplitude. Zara, what's my amplitude here? 3. Absolute value of the number in front. What if I did this? Would that change my amplitude? No. Would that change my period? No. Would it change my domain? No. Have no effect on any of those things. But the amplitude is 3. Questions on the sketch? Or how to find those 4 things? Okay. So let's look at how we can use the calculator to solve an equation. What we're going to do is something we've done before. Pretend you didn't have a trig function here. Let's say you had something like 3x squared plus 8x plus 6 equals 5. And you wanted to solve this equation on the calculator. Does anybody remember what you can do with like a y1 and a y2 and then something after that? Max?
So you graph, like, in that top example, you graph the quadratic, and then you set y equal 5, and you find the intercept.
Right. So this is just a parabola. This is just a horizontal line at 5. And the question is, where does the horizontal line in the parabola cross? When you're solving something graphically, It means to find where the two things you're looking at cross. Now, think about sine x and 0.4. We know sine x looks like this. It just keeps going. What does 0.4 look like? Yep, 2 seconds. It's a straight line where? On the y-axis. It is horizontal. And can anybody be more specific about where it is? I agree, it is horizontal. But there's a lot of lines that are horizontal. Yeah?
Is it at 0.4?
It's at 0.4. Right? So we know this would be 1. And 0.4 would be, somewhere right around there. So how many times, think about how many times the wave and that line are going to cross. Okay, so how many times, if we graph it, are the wave and the line going to cross each other? Yeah? Infinitely many. But they're not asking for infinitely many answers. They are specifically asking for all the answers that are between 0 and 2 pi. So we're going to set our window so that's all we're going to look at. And we'll find every intersection we need to between 0 and 2 pi. All right, so let's graph it. Sam, does it matter which one I put in y1 and which one I put in y2? No, we're just graphing both of them. We're just looking where they cross. There'll be different colors, but the intersection point would be the same. So let's put sine of x in y1. Put 0.4 in y2. The other thing we have to remember about the x-axis is the x-axis represents an angle. These numbers represent a low value and a high value for an angle. What are the two units that we use to measure angles? Yep. Degrees and radians. You should be able to look at those numbers and know if they are degrees or radians. So that's my question. Are 0 and 2 pi, are those degrees or radians?
Radians.
They are radians. If they were degrees, you would have seen a little circle up above them. So by looking at what they tell you that I circled in red, that's basically saying to you, put your calculator in radians. But it's not going to spell it out like that for you. Right? So my calculator is already in radians, so I'm good. Got that, got that. My window. The lowest I want to go is 0, and the highest I want to go is 2 pi. And I'm going to hit graph. It should look like it's crossing it twice. We're going to have to do each intersection separately. So second calc intersect. If we just hit enter 3 times, it should find one of them. Okay, so there's your first one. 2.73. And your second one. How do I get the other one? I can't just hit enter 3 times. I gotta be a little bit more accurate. Yep.
Do you drag your cursor more towards the intersect point?
Yep.
On one line and then do the same thing on the other line.
So we just have to move it so it's at least closer to that one. That should be fine. It should pick up the other one. So even though there are infinitely many answers to this problem, the two answers that we're looking for are 2.73 and 0.411, or 0.412. Okay. Any questions on how we graphed it and solved it? Yeah.
Is the question asked when you round it, like for the 0.4115? If it asks you to round it, you just run 0.412.
Yeah, I think 2 decimal places I think is generally what I'm looking for on the test.
Okay.
So if you said 0.41, that would be okay. Yeah. But the directions will be clear about what to round to. If it doesn't say in the homework, you could just do 2.
Yeah.
Right, let's try this one. Except that's impossible. Between 0 and 2 pi. Now, if you notice the way I write the 0 and the 2 pi, one of them has an equal to, and the other one doesn't. Because think about this in degrees. That's 0 to 360. If you're on a circle, and you start at 0, and then you go all the way around to 360, well, that's the same as 0. 0 and 360 are the same thing. That's why if you include the left edge of the screen at 0, you don't include the right edge of the screen at 360. Because technically, this point right there and that point right there are exactly the same point. It's like if you think about it in the cycle. That's the beginning of the cycle. That's the end of the cycle. But technically, that's also the beginning of the next cycle. So we don't want to include both the left and the right edge. Just the left edge. Okay, then. Okay, let's try the same thing. Now, it's asking where the cosine function is going to hit 1.5. How high does the cosine function go? Normally, yeah.
It usually goes to 1, or was it?
Yeah, it goes to 1. So cosine normally goes from -1 to 1. So normally the cosine function would never even hit a horizontal line at 1.5, because that would be too high. But why is it going to hit 1.5 in this one? This isn't just the cosine function. Yeah?
Because you're adding a transformation to it?
Yeah, we have this transformation that's going to stretch it twice as tall. So it's going to go from -2 to 2. So it will hit 1.5. If it didn't, we would just write no solution. Okay, window is already set from the last problem. 0 to 2 pi. Put in 2 cosine. For me on here, it's easier to type it in like this. 0.5x. And then 1.5. I would type it in just like that. Okay, and then we're going to look for all the places where it hits 1.5. Looks like it's only going to be one time. So this one only has one solution. Second calc intersect. I don't know why I keep doing that. Second calc intersect. And there you go. About 1.45. Any question on that? Yeah.
This is a separate question. Is there ever going to be a problem where the interval is 2 cycles and you can find all the solutions?
We are going to talk about how you would write all the solutions, like in general, but specifically exactly 2 cycles, I don't think so. Once you know one solution, it's very easy to write all of them because we know that this answer is going to repeat every single cycle. So once we know one of them, all we have to do is add something on the end of it that says, here's your answer, and it repeats every cycle. So we just have to know how long the cycle is, which we use the formula 2 pi over b. But for this one, we're not going to do that yet. So this problem has one answer per cycle. This problem had 2 answers per cycle. Now, this one, I'm not going to do the whole thing. I just want to graph it. And I want you to just be careful about something. So we've got 3 cosine, actually that's the same, and 2 sine x. So now we've got 2 trig functions we're going to draw and see where they cross. So there's the left one. There's the right one. And you just have to look at it a little bit careful, make sure you don't miss anything. How many times does it look like they cross? Yeah, no?
3 times.
Yeah, that's 3 times. So for this problem, you'd have to calculate 3 intersects. I would say up to 3 is probably the most answers you usually have in a cycle. But 1, 2, or 3, those are pretty common. Okay, so any question on how you do the intersection points? Okay, last one. Instead of solving where we have an equal sign here, now we're going to solve where we have a greater than or less than or an inequality. It's still the same idea. The difference is your answer now is not going to be x equals a number. The answer now is usually an interval between here and here. And sometimes we use the union symbol, and then we have another interval. Okay, well, let's start the same way. We're going from 0 to 2 pi. That's pretty common. So once you put that in there, you're probably pretty much set with your window. Put in 2 cosine x in y1. Put in negative 1.3 in y2. And we're looking for where the cosine wave is above the horizontal line. That's what we want to know. Where is the wave above the horizontal line? Here's your sketch. Could you trace where the wave is above the red line everywhere without lifting your pencil? No. That means you're going to have to describe where it's above the red line in 2 pieces. This is piece 1, and then this is piece 2. We need to describe each of those pieces. Now, let's think about the endpoints of these black segments I just traced. Does it say we have to be above the red line, or does it say above or equal to the red line? Which one? Yeah?
Above.
It says above. It does not say equal. So that's an open circle. Same thing here. It's above the red line, not equal to the red line. Now, let's look at the left end of this interval. Where is the very left end of interval 1? Let's start writing our answer. Oops, I think I moved it a little. That's okay. Where's the left edge of interval 1? Look at the screen. Yeah?
At 0.
That's 0. Can we include, or do we not include the 0? Yeah? We do include it. We do include it because it says to include it. So that means interval 1 starts at 0, including it. And I don't know where it's going to stop yet, but I'm not going to include it. I know that much. For interval 2, I don't know where it starts, but am I including where it starts? No. I have to find where it starts in a second. And look at where interval 2 stops. Where's the right edge of my screen? About 8. Where's the right edge of my screen?
The right edge. 2 pi.
Do we include 2 pi or do we not include it?
We do.
Well, there's no equal to under that symbol right there.
Oh, no.
So no, you do not include that value right there because it said not to. Okay. So now I know pretty much what my answer is going to look like. I just need to find these 2 things. how am I going to find the two numbers I need to put in at the end of interval 1 and the beginning of interval 2? Definitely.
Those are your intersections.
Those are my intercepts. So that's where it's the same as what we've done before. So calculate your intersect. Let's go to the left a little bit. 2.28 is the first one. So that describes where we are above the red line in interval 1, from 0 to 2.28. Interval 2, second calc intersect. Should be good enough. 4, but it's almost 4. 4.00. So from 4 to 2 pi, we are above the red line again. Now, how would you describe where you're below the red line? From what number to what number? You have all the information right there. You don't have to do anything else to describe that. Caleb?
From 228 to 4.
Yeah, between 2.28 and 4, that's where you're below the red line. But in this case, they weren't asking where you were below. They were asking greater than, okay, where you're above. That's it. Any questions on that? So you will need a little bit of graphic calculator tonight to do intersections. Other than that, everything else you won't need a calculator for. Okay, so that's the homework for tonight. What I'm going to do is I'm going to pause it, and I'll put the test topics on the video. I might have enough time to get them done right now. Okay, so we'll do that.